Alrighty, good morning, everyone, and thank you for joining me today. This is KETIV Virtual Academy, brought to you by KETIV Technologies, of course. I'm your presenter and host, Brian Molkopunczyk, Customer Success Manager here at KETIV Technologies. And I said good morning, but it could also be an afternoon for you over there on the East Coast. So thank you all for joining at whatever time zone you're coming from. Today, we'll be diving into the persona, the extension, nesting, and fabrication inside of Fusion 360. So if you have the product design and manufacturing collection, you have this inside of your toolset, or you at least have Fusion 360 inside of your toolset. The nesting and fabrication is an extension as to that. So let's go ahead and dive right on into it. Here's an agenda of what we'll be going over today. So essentially, from start to finish, how nesting would work inside of Fusion 360. Mind you, if you are using Inventor, you do have your own nesting utility inside of there. This has been out in Fusion for about a year now. I know it's been in preview mode, and they've made some improvements and modifications to it, along with a lot of other extensions as well. But today we'll be tackling the nesting side of it. So the first example we'll be showing is the sheet metal, a general sheet metal example from start to finish. And then at the end, I'll do a quick like fabric example, or a non-sheet metal example, if you will. So if you have any questions at all, definitely put those in the comments, and I'll try to get to those as we go along here. Quick intro about me. I've been at KETIV for about 5 years and 8 months, to be exact, according to LinkedIn. I'm a customer success manager that helps customers at KETIV with the adoption of the tools and services we provide. And previously to this role, I was an application engineer for Fusion 360 here at KETIV for about 2 years or so, prior to moving over as a CSM, if you will. And a little fun fact about me, I love 3D printing, as you may have seen some of my webinars in the past about this. And I've 3D printed my own board game at home. That's like a medieval themes or medieval times theme. So talk to me about that. All right, so let's go ahead and dive into the meat of it. So nesting and fabrication. So what Autodesk has been doing the past year especially is, instead of having the software or the users of the software kind of cater to the software and try to find which software and tools work for them, they flipped it around. They want to cater more towards the users or the personas, and by making personas in this case. So they're targeting and making sure people who are using something like nesting and fabrication, for example, are getting the exact extension they need. Hence this tool, the nesting and fabrication tool. And just a little bit quick on pricing, just to give you maybe a straightforward idea, common sense purchasing option. The extension for nesting and fabrication for Fusion 360 is $1,600 in addition to your Fusion subscription if you're buying Fusion standalone. So that'd be $1,600 a year. Versus if you were to buy the extension on a daily basis, that's like $11 or $11 a day. If you multiply that by 365, that'll be about $4,015 there. So just keep that in mind if it makes more sense to commit to the 1 year, or if you're only using nesting a couple like a day or two a week, then maybe the 1 day pay-as-you-go option makes more sense for you. All right, with that said, I'm going to blind you with this red screen, and we're going to head over to Fusion 360 itself. So I got this bird feeder off of GrabCAD. I actually redesigned it because it wasn't exactly the way I would expect it to be set up here on the browser. In order for the nesting for sheet metal to work properly, you're going to need to have a flat pattern for each of your sheet metal parts. So let me delete this as an example. So this basket here that holds the bird food does not have a flat pattern anymore since I deleted it. All right, so the first step of that agenda you saw, we're going to go into nest preparation. So that's right here on the design workspace. And let's go ahead and expand this box. If we can. There we go. Oh, there we go. So first, it'll tell us what it tries to ignore. So it's ignoring the sketches right off the bat. We don't need it to nest any sketches that we have here. So that makes sense that it would ignore that. We want it to not ignore sheet metal. We're trying to get the sheet metal components here. And then the other one is anything we select as something we could potentially ignore. Then down below here, it tries to auto select the right component type. So if we're taking a look here, the basket that we deleted the flat pattern for no longer is detected as sheet metal because that sheet metal or the flat pattern is gone. And if let me move this to the side here. If we take a look at our model, you can see that instead of a flat pattern like the rest of these pieces have, this one has the basket still. It's still intact and not flattened. So even if we try to change this to sheet metal, it's not going to be happy with that. So what we're going to do is just Control Z to undo the deletion of the flat pattern. And let's go back to the nest preparation again. And there's our flat pattern for the basket. If we go down here, everything is good in sheet metal. We don't want the glass panel in the front. So let's move this out of the way. We don't care to nest this glass panel in the front because that's not metal. Nor do we want this plastic or whatever material stand that the bird perches on. So we're going to choose to ignore both of those as well. All right. Pretty straightforward. This gets you ready for the next step, which is going to the manufacturing environment. And next on the list is materials and packaging. So we go to fabrication. Under here, we have the process material library. And before I move forward, I do want to click on this extensions here just to show you what you need to have purchased. I think I did on a daily basis here because I have a lot of cloud credits, clearly. But this is where the persona of nesting and fabrication lives, as well as some of the other personas and extensions here that we can dive into at another webinar. So going into the process material library, as you can guess in the name, the material is what we're kind of defining right now. This is a sheet metal part. So we're using steel in this case. I'm not going to dive into the details of, exactly which sheet metal does what. The settings are all here for you to play around with, but I can give you a general run through of this. So for example, if we're looking at steel, we can see the thickness and define the thickness here. We can override the thickness in this setup space, different from what was in the design space. And you can specify the color. This will show later when you do a report or where you do a comparison to help differentiate the multiple different thicknesses and materials you're using. And if we go over here to packaging, this helps you to determine not only the size of the different raw materials you have at the fab shop, for example, but also the cost. And the cost shows actually pretty well in the reporting, which I'll get to at the end. So if you have parts of the bird feeder being cut up, it would show you how much that material costs. It would divide it, like if you're using 50% of the raw material and it costs $1, that would be 50 cents of material that you're using. Something very, very straightforward like that in the reporting. So we have packaging 2, which is a 500 millimeter by 500 millimeter sheet of metal, which is in inches, about 20 inches by 20 inches. And then we have another raw material, which is 40 by 20. Moving over to the nesting tab here, this is where you can determine or limit how much or how little it can rotate when trying to fit these pieces of these components onto a sheet of metal. So it can rotate, 90, 180, 270, and then you can deviate it from its original position here. So if it's at 0 degrees, it can only rotate 90, 180, 270. If you put this to 30 degrees, for example, in increments of 1, it can rotate 91, 92, 93, 94, all the way to 120, perhaps, in increments of 1 degree. So that can be determined here. But keep in mind that will also play a factor with the material grain. I like to think more of like wood grain as a better example, because I see that more visibly. So if you have the grains of a wood showing one certain way, maybe parallel with the material or parallel in which it was cut, it might look better or might perform better, as opposed to if you were to increase the degrees here in which it can be flexible, it might not be produced as cleanly, if you will. So I'm going to turn these back to 0 for now, or let me just get out of that and go back in there. Make those 0 for now, and I just wanted to kind of verbally tell you what they are there for. Frame width is the edges of your raw material, so you don't want the cuts to be anything outside of the edges of 10 millimeters, as well as item separation. This is in between each component, each components of the bird feeder. And if we look at this pre-kit checkbox, this allows the 2 instances of a component to be kind of knit together to be one part, like the first example in the green there. So by leaving that check, which I recommend, it'll allow you to kind of save more space for nesting here. All right. So you can also add other custom materials here, and you can save them as a preset. So if I hit OK here, we're good with this steel with the packaging 2 and packaging 3 materials here. I can show you under process library, material, and packaging presets. You can add it and save one here. So if you're happy with the materials you had saved there, you can save that here. And then if we go to our data panel, let's go home and then all the way down here to assets under Nest materials. These are saved here. So in case you want to reference another material library, you can do so here. And we'll be coming back to the assets for the report templates as well. Those are also located in this data panel. All right. And next on the list, component sources. So instead of defining how things are oriented at a material level, we can define them at a component level. So on the left here, we see all the different components that we chose to utilize for the sheet metal. You can see here, it's not populated for glass and stand. That's because they're not sheet metal. And then they're showing some of the flat pattern down below here. So here, let's say one of your baskets broke and you needed, during this nesting operation, you wanted to add one more because of the other one failed, the other one didn't work out. You can go ahead and click this override nest quantity. And you can change that value to 2, for example, for this nesting operation. So that's what you can do here. I'm just going to turn this back to 1, or you can make it 0, I guess, in that case, and just get rid of it. You can also override the nest material If you don't want it to be steel and you want it to be something else, you can specify that there, as well as the orientations can be specified at the component level rather than the entire material level. Like, let's say you only wanted one of these components to have the orientation flexibility, and then the other ones you wanted to keep stagnant. Then you have options to view the flat pattern and what you have selected here. Just as an example, it's a visualization to help you on your way. All right, now that we have the component sources and material specified, we can now create a nest study. This is essentially the last step to it. So first tab, the study tab, we can add comments, we can specify the job quantity. So this is pertaining to if you have multiple like assemblies in here, for example. Right now it's set to single value because we just have one, and we're trying to create 15 instances of this bird feeder. We want 15 bird feeders. But if we set it to multi-value, it would show multiple different assemblies here. It's only showing one, but then you can specify, I want 15 bird feeders. I want 5, I don't know, pig feeders. But you can specify that at a multi-value job quantity. Stack size would be the number of sheets that you have for it. So if you wanted to span this across more sheets, you can do so with the stack size. And then we'll leave some of these options checked there. This tab just shows you which shapes that are included, which components, just kind of reconfirming what we looked at in component sources. It looks like 90 parts are going to be nested here. Kind of gives us that summary. Let's see if there's anything else worth mentioning at this level here. And then we are coming down to packaging. So this, whereas previously it didn't give us an option, this gives us the inventory quantity here on the right-hand side. Right now it's showing us that we have an unlimited amount of packaging number 2. So the 500 by 500 or 20 inch by 20 inch sheet of steel. We can change that. We can't just type in the number here. We actually have to right click it and then hit multi-edit. I don't know who put this number here, not me, but I'll put a 1 there. And let's say we have 1 packaging to raw material in the fab shop. And then if we go up beyond the extent of that, we can do so we can add more packaging material by double clicking the available ones down below here. Now we just added our packaging 3 material to this. That's the 40 by 20. And we'll just say we have an infinite amount of that. And then if you scroll down below here, it's kind of subtle if you didn't expand the page. Not that it's going to allow me, of course, right now. But if you scroll down here, you have 3 different options when it comes to packaging. You have the as listed. So whatever order you end up choosing here, in this case, packaging 2 will be prioritized and then packaging 3. That will be one of the options. The second option is best size. So if you, it says right there, you can, it'll put it based off which is the best size to use, not caring about really anything else besides that. But then there's also the option for best mix. So it's a combination of both the cost. So if you put like packaging 2 would cost $1,000 and packaging 3 costs $1, it might lean towards packaging 3, for example. And also try to combine best size as well for that. So we're going to do as listed for now because we want to incorporate packaging 2. Global parameters is next. So this allows you to specify where it starts or where it's going to derive it from or start from. So we're going to start from the lower left, so it travels the least amount of distance, because that's usually where the 0 work coordinate system is. And then we have some compute times we can specify here. You'll probably want to give it more compute time if you gave it a lot of derivations for the angles that we saw earlier. But this is the out of the box, default times that it gives us. The desired yield is the percentage it's going to try to achieve when the percentage of the raw material that it's trying to cut. So it's trying to be as efficient as possible. So it's going to shoot for the 80% there. And then remnants, that'll be the word of the day, remnant optimization. So this will be something that leaves the raw material for you to use at a later date. So if you're just doing minimizing the width, let me get it to show here. There we go. It will try to squish everything to the bottom of your packaging. If you minimize length, it'll squeeze everything to the left. And if you minimize length and width, it'll try to squeeze it into the corner, which is what we want here. And then with what you have left, so for example, if you had this minimized length, everything where this arrow resides on the right-hand side of that line, that black line you see here in this image, will be the remnant, the dropping, if you will, the leftover of your sheet metal. All right. Output, 3 boxes we can check here. Create manufacturing model. Leaving that check gives us the 2D flattened out nest that we want to send to maybe if you want to laser cut it here and there, or here and then, you can leave that check, which we will. Show part outlines. This one kind of creates like some blue lines that go around your sketch or your flat pattern. So we'll leave that check, and I'll draw our attention to that. And include stock, which will show the 500 by 500 millimeters stock, like a transparent kind of stock, and maybe the 1000 by 500. So that'll just show the raw material that it starts off as. Enough talking. Let me hit OK there. And it's generating here real quickly. So it looks like it created 2 sheets. So each nest has material and thickness specific to it. So if we had multiple different types of sheet metal in here, it would have multiple different nests, but that's not the case here. We just have multiple different sheets. So looks like we have our results here. Rotate that around. I think I set it to generate 15 of these. So as you can see, there's 9 of these here. So they're not trying to fit all the components of it in one sheet, if that makes sense. So for example, it could fit, if it made sense, it would have fit all of these sheets on one, and then it would fit the rest of its counterparts on another. It doesn't care for trying to fit one whole bird nest on a single sheet. You could fit half of it on one and half of it on the other about these 2 sheets here. So you can see this is using the packaging 2, the 500 by 500 that we defined and told it to. And then this is using packaging 3, which is the 500 by 1000 millimeter. And here's the remnant line that kind of says, hey, you can use this piece of sheet metal for something else later on. And everything in blue here, or the highlight in blue, that's the part lines checkbox that we left on as well. And then looking at the bodies, there's the stock that we told it to generate to give us that idea. Now that we have these created, we can compare them. So if we hold Control, selecting both of them, right-clicking and comparing. And as you may have saw the gray color earlier, it's represented here in this compare box. And you can see the efficiency of the first one. 78 is pretty good, close to that 80% there with the thickness and even the cost. So this is where the cost comes into play. It's pretty straightforward because it's just using one sheet. The reporting melt will give us a more definite or more granular result. And then the other sheet here, 52% is not as good because there's that extra space there, but that's what we're working with here. So you can change this as you will. And then some other information there. Next, let's look at the nest reports to look at it more granularly. So if we go to right click the nest, we can regenerate it if we made some setting changes by going to edit nest, or we can go here to report. And this gives us an HTML report. This HTML report can be customized. If we go here to the data panel and you go under nest report templates, there it is right there, the default report template. If we open this template, it'll open in our Fusion team, the data management portion of Fusion. And what Autodesk recommends is if you want to make changes to it, the original one, you want to go ahead and create a copy of it. I went ahead and did that and just named it copy. And then if you want to make modifications, now you have a fresh copy to modify the report without actually affecting the original in case you mess something up. So here in the report, we have more granular information, like I was saying, different grain controls, orientation. Let me look for the cost as well. There's a cost up here. There's cost right there. That's for the sheet. Let me look for the lower level one, but here's some of the layouts. It shows oh, here we go. Here's the more granular cost. It shows the count of how much of each component is in that sheet or in these sheets. Here's the amount of material cost. So it looks like the wall underscore hood took approximately 61% because of the $1 steel. So it took up a majority of it, whereas the rest of it took up a lot less, as you can see there. And then here's the second sheet. And it shows the efficiency again down below here. All right. And then let's think about the two output exporting options. So you have DXF, which is very generic 2D way to send this out, or you can create the toolpaths in here itself. So let's start with the DXF. So if I want to create a DXF of this one, for example, I can right click export and save it as a DXF. I'll save it to the desktop sheet 30. And then it gives us this window. Before doing so, let's go ahead and hit preview. And that's roughly what it's going to look like. We'll go ahead and open up the DXF after we're done here. So now that it is created, I think it was 35. This is sheet 30. Hold on, give me one moment. Let me see if I actually exported that. Export. Okay, I saved it here. Let me see if I can go to quick access. Okay, this is my savior for File Explorer. Just going to quick access and finding it there. So I'm just going to click on that and open it up there. You don't really see anything here. That's because I need to hit home and then I'll zoom out to my DXF for the model. And that's what you're exporting out to whomever you'd like. And this, if you don't know about Autodesk DWG TrueView, this is a free viewer. You can Google search, download, and view your drawing files or DXFs. All right, so that is one way to send that out to the fabrication to be fabricated. And then the next option is to create the toolpaths for it in Fusion here. So if we go here to 2D profile, we can select the tool we want to cut with. I want a laser cutter. So we'll go ahead and select that. And I'm not going to really need to press any settings here. Okay, maybe I need to select the contour. That'll select the whole thing. Let me hide the stock material there. And I'm going to select same plane faces. So then if I select one of these contours, it'll select all of them there. And then it's going to go ahead and create the tool pads for us here very quickly. Move this guy out of the way. You get the idea there. And then you can export this to your laser cutter, water jet, plasma cutter, what have you, and it will be machined. All right. Oh, it looks like we did have some questions. Rodney, sorry, I was not looking at the questions. Let me pause right now to take a look at those. Let's look at the first one from 7 minutes ago. Does this allow for different post processors such as large plasma tables with bevel heads? And can you assume common line cutting? Not too sure what common line cutting is, but for different post processors, you can take a look at and definitely email me after, or I'll reach out to you, Rodney, after to see which post processor you're using. But if you haven't seen it already, Fusion 360 has a list of post processors and machines that it's compatible with. So we can take a look if your machine is on that list first and foremost. And if it's not, we can see what we can do to go about that. Can you program scribe marks for bending and part numbers? So scribe marks for bending and part numbers. So I will need to get back to you on that. I'll run that by maybe our CAM specialist. Alex, he might be on the webinar now. Maybe he can take a look at that question for you. I don't have the answer for that. And then you use TrueNest with Autodesk. And you currently use ProNest. Can you set this to use the REMs before using larger sheets automatically? You set this to use REMs before. Not sure the answer to that. Again, let me get back to you offline, Rodney, before I make any false statements in regard to that. Question from Jacob: if an assembly has different size sheets, will it create different size sheets? So if you have different packaging, then yeah, it will create different sheets like you saw here. If your assembly had different, so if your assembly had different thicknesses of metal, different types of metal, yeah, it'll create a different nest. When we hit that generate nest, Jacob, it'll create, instead of like a nest 1, nest 6 here, it'll create like a nest 6, a nest 7, a nest 8, depending on how many different thicknesses of materials you have. So I just showed one material, one thickness, one nest, because each nest is its own thickness and material. So good question. But yes, it would. It just didn't show that for this example. All right. So that's it for the sheet metal example. I was going to show in like 5 minutes or so maybe a cloth example, or if you wanted to do nesting with just an idea of sketches you had in your head without having to dive through flat patterns and things like that. That's what this quick second example will show. So the example I have are these 2 pieces of cloth, if you will, and you can imagine these as sketches. So like you have this rhombus with filleted edges there, as well as this like Band-Aid looking piece, and you want to nest these 2 in what we just saw. So first and foremost, I tried doing these as sketches immediately, and they did not work out. So what I had to do was extrude them to have a 3D body so then it can detect it properly. That's just the workflow I ended up going with. Let me know in the comments if you found a workaround to that or if you got the sketches to work. But that's what I ended up going with. So now that I have my, let me go back to the design workspace. Now that I have these thin sketches extruded to have some thickness, we can do what we did in the previous step, which was the nest preparation. And it's going to go ahead and detect these entities. It's highlighting it in green, which is nice. So we'll go ahead and hit OK for that. So yeah, again, if you want to just use the nesting environment for just your sketches, for your ideas to put on a piece of paper, fabric, what have you, that's not sheet metal. This is what you should follow, or what you could follow. Let's go over to manufacture. Process material libraries next. Instead of the material 3, which is the steel, let's look at material 1, which is just set as generic. And sure, we can go with the 2 millimeters thickness here. I just want the DXF, for example, for this, and it's going to be represented by this pink color. 1,000 by 1,000 piece of fabric, 40 inches by 40 inches there. And over here, maybe we can specify the deviation to be, I don't know, 45 degrees for every, and increments in every 1 degree. And we'll leave everything else as is. And this is going to be the default packaging. As you can see, it's bolded there. So if you right click and just set that as default packaging, that is what it will use when you try to go to component sources or the nest. So we can just take a look here of the different orientations. Actually, you know what? I wanted to, let me just do it the right way. I wanted to specify, oh no, actually make these 0. It's not letting me put in 0. That's interesting. Gonna have to just do that real quick here. Don't let me put in the 0. It's interesting. Uh-oh, here we go. 0 degrees. All right, we will leave it at that. I'll come back and troubleshoot that on my own time there. It's giving me an error that doesn't like it though. Maybe I'll do at least 2 degrees. Okay, where was I? So I wanted to specify that this component here, the Band-Aid looking component, was going to be the one that can orient more than the other one with an override. So this one here, I was going to say, you know, orientation of, oh, I already said it there, 45 degrees. So then when I go to create the nest study, the Band-Aid one can flip around however it wants, but I want this one to remain more stagnant on the left here. Going to the nest study, yes, we'll create 15 of them within our 40-inch by 40-inch packaging. I will leave the compute time the way it is, and I might increase it if it gave me a weird result. And then, yeah, let's go ahead and just hit OK there to generate this, and then we'll see what it gives us. All right, so the reason why I set that to 45 degrees, because now I was able to get it to flip way dramatically, whereas if you remember before, it was kind of sideways like that. Now I gave it the flexibility to rotate sideways to fit properly here between each other there. And it looks like it was able to fit within one sheet too. So that's really nice. And then same as the sheet metal, you have the options to export as a DXF. You have the options to go into create tool pads for it. But if this is like fabric, for example, you're just going to cut it out or whatever you do to deal with fabric there. I do see more questions come in, so let me just go back to the PowerPoint. That is it for the nesting side of things here at a very high level for both sheet metal and maybe like a fabric example or a sketch example here. So real quick before I answer those questions that came in, here's some additional resources I can put in the chat room. One is a video tutorial that I found really helpful for learning nesting, like in a step-by-step, similar to what we did today. So let me put that in the chat, and then I'll put the other one in the chat room as well. That one's to panelists, so let me send that to everyone. Do that again. There we go. Video tutorials, and then the product documentation. So this is just kind of, if you just want to read about it, that's what the second link is for. And then upcoming events, I will be doing with Autodesk a What's New in Fusion 360 KETIV Virtual Academy on June 16th. We'll be going over what's new. I'll be going over the what's new in design over the course of January through May, essentially. And then our friends over at Autodesk will be going over what's new in manufacturing. So stay tuned for that. If you're not already subscribed, which I think you are, then make sure to subscribe to get the notification for that webinar. All right, thank you guys for watching. Let's go ahead and look at the questions here. So Rodney, I currently use Inventor. Will nesting work with Inventor rather than jumping out to Fusion? There is a nesting in Inventor that's actually older than the one that came out in Fusion here. So I recommend, if you have Inventor or the collection, to access the Inventor nesting utility there. If you don't have the collection, I think we will need to reach out to you and talk to you about what makes the most sense, Rodney, which option is the most like effective for you. But if you are using Inventor, definitely use the Inventor nesting that already lives there. Kenneth, we bevel cut, so will it recognize what edges are beveled? So that would be more of the CAM side. When I was creating the toolpaths for it, I think you would specify that when you're creating the toolpath of, I want to maybe run a different toolpath. I was just showing a very generic 2D profile cut. So if you want a bevel cut like that, you might want to run a different toolpath that maybe is a certain distance from the edge, right? So that might be something more of the CAM side of things, but you can specify that inside of Fusion. It just wouldn't be maybe that laser cut option, maybe just like a 2D profile toolpath you run on that. I think, oh, you have the collection, Rodney, perfect. Then yes, you can use Inventor, the Inventor nesting utility there. I'll reach out to you after this because I want to answer your other questions, but you could definitely do so in the collection then. That's good. These are great questions. Thanks for asking, everyone. Yeah, other than that, yeah, stay tuned for the Fusion 360 What's New that I'm collaborating with Autodesk next month, June 16th. So save the date and same time. And if I don't see any other questions coming in, I appreciate everyone's time. Yeah, thank you. Thank you for joining. Thank you for everyone's time. You guys have a great rest of your Thursday, great rest of your week, and happy Cinco de Mayo as well. We'll talk to you guys soon.